this video, I want to talk about graphing a parabola of the form y equals ax² plus bx plus c with rational coefficients. That means fractions. So I know that you don't love fractions, but we'll try to make it as painless as possible. So first, we have it in this form, right? Y equals ax² plus bx plus c, but we want, in order to figure out the vertex and then be able to graph it, this is one way, right, to turn it into this form of equation. And you do that by completing the square. However, in the last video, we learned that there's another way to do that, and that is to recognize that the x-coordinate of the vertex is equal to negative b over 2a. So we can use this to figure out what the vertex is, and then we can just graph it that way. So let's go ahead and try that. So the x value of the vertex is going to be negative b over 2a. So this is a, and this is b, and this is c, right? So negative 1/2 over 2 times a, which is 1/2. So 2 times 1/2 is just 1, so this is just negative 1/2. To find the y-coordinate of the vertex, we can just plug it in. So y of negative 1/2 is 1/2 times negative 1/2 squared plus 1/2 times negative 1/2 plus 9 over 8. Okay, so now 1/2 times 1/2 is 1/4, times 1/2 is 1/8, and that negative goes away because we're squaring it. So this is 1/8 plus 1/2 times negative 1/2 is negative 1/4 plus 9 over 8. So now I'm going to change this into eighths so that we can add them. So we have 1/8 minus 2/8 plus 9/8, which is equal to 1 minus 2 is negative 1 plus 9 is 8. So it's just 8/8, which is just 1. So the vertex is, so this is the y value of the vertex, right? So the vertex is negative 1/2, 1. So we have negative 1/2, 1. So right here. And this is an up-opening parabola because this is positive. So now we can just use a t-chart to graph some points that are in the area. And I will just go ahead and use the closest points, and I'll go ahead and use whole numbers just to make life a little bit easier. So let's use negative 2 and negative 1 and 0 and 1. And these points are symmetric, so they should have the same, so this should have the same y value as, negative 2 should have the same y value as 1, and negative 1 should have the same y value as 0, because it should be symmetric around the vertex. So that'll be a good way to check, especially since we're using fractions. So let me go ahead and erase a little bit of this work here so we have some room to do some new work. So we're going to start by plugging in negative 2 into this function. Okay, that should be good. So we'll have y of negative 2 is equal to 1/2 times negative 2 squared plus 1/2 times negative 2 plus 9 over 8. So this is negative 2 squared is 4 times 1/2 is just 2 plus, this is going to be negative 1 plus 9 over 8. So this is going to be 1 plus 9 over 8, so that's going to be like 17 over 8, which is just over 2. So just a little bit over 2. All right, let's try -1. So y of -1 is 1/2 times -1 squared plus 1/2 times -1 plus 9/8. So this is just a half minus 1/2 plus 9/8. So that just equals 9/8. So this one just equals 9/8, which is just a little bit over 1. And then y of 1, y of 0 should just be 9/8, right? Because if we put in 0 and 0, we'll just get 9/8 left. So this should just be 9/8. So that's good because the symmetry says that that's what it should be. And then one more point is 1, so y of 1 is 1/2 times 1 squared is still 1 plus 1/2 plus 9/8. So that's 1 plus 9/8, which is 17/8. Because 8/8 plus 9/8 is 17/8, and that gives us good symmetry over here too. And so our parabola should look like this. And that's how we graph a parabola of the form y equals ax2+bx+c with rational coefficients. Now remember that you can also do it using this formula. You have to complete the square to go from this to this. And that's also an option, but I think that especially when we're dealing with rational coefficients, it's a little bit easier to just start by knowing that the x vertex of the parabola is -b/2a, and then just plugging that in to find y.